friends. Now my next sum is based on a mensuration, you can say rather. So this is a kind of mix mensuration and you can say arithmetic also. So let me explain. Let me explain the problem. Problem says let S1, S2 dot dot up to Sn are squares. Okay, these are the squares where for each these are the square for each n greater than equal to 1, means here if n value is 1 or more than 1, it follows a rule that says the arm length of n will be equal to the diagonal of the next square. So that means if I take a square, the first square, let's say a1, the arm length of a1, let's say it is a1, and the second square whose arm length is a2 and it is represented by the diagonal d2, then a1 has to be equal to d2. So this implies here. So as per the condition, for any value of n greater than 1, arm length of the first square will be equal to the diagonal length of the second square. So this is the condition, and also given that first square arm length is 10. Okay, now our task is to find for what value of n your area of Sn, means Sn is represent a square, the area of that Sn should not be more than, means it has to be less than 1 square centimeter, as because the arms are in centimeter, so that area has to be less than 1 square centimeter for what value of n. This is your task. So let me repeat again. S1, S2, S3 are the squares in a system where for any value n greater than 1, this relation follows. An, that means arm length of the first square, is equal to the arm length of the next diagonal. The arm length of the first square is equal to the diagonal length of the next square. So another thing is given, that the first square arm length is 10. Now you have to find for what value of n. N is a real value here. You have to understand that for what value of n, the area Sn is less than 1 square centimeter. Now let me start the solution. This is very interesting again to understand. So if I see, there are two things as per the condition given. I can say that a1 is equal to, as per the condition, is equal to the d2, where I am considering the arm length of the square represented by a1, a2 dot 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 n, and diagonal lengths are d1, d2 dot 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 dn, and the area of this respective squares is represented by capital A1, A2 and dot 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 an. This I am assuming as a terms of the sum. Okay. Now as per the condition of this sum, this the arm length of the first square is equal to diagonal length of the next square. So this is true if I take it. Now another condition which is very natural, for any square the arm length is the diagonal by root 2. This also implies good. So if I go like this, what would be your A2? A2 would be D2 by root 2 as per the condition. Okay, now A2, if I see it, D2 is your A1, so I can put the value of D2 here, so I will find A1 by root 2. Now as per the condition, as A1 is equal to D2, A2 would be D3. I can conclude that this would be your third. By that, if I go to A3, it will give you in a similar way. I can also bring it to the relation of A1. How? Because A3 is D3 by root 2. Now D3 is equal to A1 by root 2. That means A1 by root 2 into root 2. Here I want to represent it in a common form, in the form of power. If I take this, this is nothing but square. So if I want to relate with this term, so this will be represented at 3 minus 1. Here this the similar one I can represent it as A1 upon root 2 whole power of 2 minus 1. That also implies this one. So if I say what would be your an, that will give you A1 upon root 2. If I follow this term, it would be n minus 1. Okay, so up to this I think it's very easy to understand. Now what would be your an then? An, I have taken an area of that, so it is nothing but an square, because this is a square as a form, because all are square. So arm square will be your area. So this is nothing but A1 square by root 2 by whole to the power 2 n minus 1. Okay, now as per the condition of the sum, it is given that the area should not be less than, if I take this condition is true, so root 2 whole to the power 2 n minus 1 is less than equal to 1 square, because this is square, this is also to be square. Now I can say root 2 whole power of 2 n minus 1 is more than a is given as A1 is given as 10, that I said earlier. So this is 10 square, that means 100. Okay, now 2 to the power n minus 1 greater than 100. So now you have to find the minimum value of n for which this condition is true. So n could be any value for which that 100 could be crossed, but why it is crossing 100? 2 to the power 6 is how much? 2, 4, 8, 16, 32, 64. So this is equal to 64. Now 2 to the power 7 is your 128. So this could be the minimum number for which it is crossing. So if I say the minimum value of n minus 1 has to be equal to 7 for which this value will cross this. So n is equal to your 8. So this will be your answer, where you have to find that what is the minimum value of n for which this condition implies. So here is your solution. So that's for now. Kindly see my videos. It will be very useful and interesting videos, not a monotonous one. So I am trying to bring more interesting sums like that. I am studying more so that you will be helpful if you follow it. So kindly follow and subscribe my channel and share it to your groups. Thank you.